Hi, everyone, and thank you for being here for my talk, Challenge Accepted, the journey of mathematical memes from social media to the mathematics classroom. And a special thank you to Dorota and Dylan and to the YERME board for inviting me, for risking inviting me about this strange subject. So just a few words about me to introduce myself. I live in Milan and I work at the University of Turin in the north of Italy. I have a master's degree in pure mathematics in differential geometry and a PhD in mathematics education. And I have worked 25 years as a high school maths and physics teacher before taking my PhD and pursuing research. My research interest is on the interplay between mathematical culture and digital culture. And I like traveling, cats, and as I am Italian, good food and good music. So this webinar will be on my PhD thesis. The title is Mathematical Memes from Internet Phenomenon to Digital Educational Resource. And the research has been conducted under the supervision of Ornella Robutti from the University of Turin in Italy and Angelika Bickner-Asbas from the University of Bremen in Germany. And I defended my thesis in last May. I will start this webinar from my personal Big Bang, which was in February 2018. I was still a teacher then, a teacher and a PhD student. And I found this object on Facebook prompted by my students. And I realized that this object that has an evident mathematical content is not a simple viral object, which is simply copied and shared on the internet. This is an original creation. It is the mathematical mutation of a digital object known as internet meme. Richard Dawkins coined the term memes in 1976 to identify the unit of human culture that is passed from one person to another by imitation, in a parallel to the gene as the carrier of the unit of biological heritage. But in the web, this term is used to identify digital objects, text, images, or videos with the humorous content that are copied, personalized, and shared online by internet users. And a subset of internet memes are image macros, which are internet memes built through images, design mutation of images that are humorously reinterpreted. And my focus is on mathematical memes in the form of image macros with the mathematical content. So I set off for this research, whose objects are mathematical internet memes. And my purpose was gaining insight into this internet phenomenon to figure out if and how this digital object could be transformed into traditional educational resources. And the rationale for this research was the idea that mathematical internet memes could establish a relation between mathematics education and other practices that are connected to young learners' digital culture. So the main question that guided my research is how can we conceptualize mathematical internet memes and what are the educational potentialities, if any? In the summer of 2018, during my first year as a PhD candidate, Dylan is laughing because she recognized herself in the image. I attended the YES9 in Montpellier, the YERME summer school, where I met Dylan. And I presented my research idea, which were really at a very, very, very early stage. And my tutor there was Angelika Bickner. And she explained us the research pentagon that you can see on this slide. The pentagon is a diagram representing the 5 aspects to consider in building a research. And in my naivete, I was relieved because I thought I have the research object, mathematical memes. I have the research aim. I want to find out how to transform them into an educational resource. And I have the research question. Now I just need to work on the situation and on the method, and it's done. So I have my path clear ahead of me. And so this was my expectation. I imagine a linear path, and this is how things rolled in reality, with a lot of crossing paths and new idea to deal with along the way. And it was really not a linear one. To borrow Michael Collins' words, I can say that mathematical research is a journey, not a destination. And when you get there, you find you want to reach somewhere else. And one thing that complicated the research was the fact that when I started, I could not find any literature about mathematical internet memes at all. So on the one hand, the lack of literature suggested that this research could fill a relevant gap and could be useful in the academic world by opening new research paths. But on the other hand, this represented a challenge because I did not have anything to rely on in terms of guidance, in terms of suitable theoretical frameworks and research methods. So to find my way through this new territory, I split the question into two parts. And I tackled with different approaches. The first part was addressed in ethnographic research, with the aim of revealing what mathematical memes represent inside the online communities who act on them, following the theoretical framework of convergent and participatory culture as exposed by Jenkins. And the second part of the research question was addressed through an experimental research that involved different theoretical perspectives in a bricolage stance that aimed at maximizing the understanding of the phenomenon, which was unknown, by observing it from different standpoints. And here, the investigation focused on memes' educational potentialities to carry meanings and initiate mathematical discourse, following Sfard, ignite emotions, following Zahn and Radford, activate learning mechanism at the boundary, following the traditional literature on boundary objects by Starr, Griesmeyer, and Ackermann and Bakker, and the latest implementation of this theory in mathematics education by Robuti et al. To channel students' visual skills, following Presmet, to channel students' digital culture knowledge, following Ito et al., and to foster changes in student praxeologies, following Chevalard. Opening up the research question into different sub-questions made it more manageable. But nevertheless, there were challenges at different levels. The first challenge was meaning making. That is to say, decoding the object of the research, which is quite unusual because usually we deal with objects we fully understand. And the second challenge was conducting the ethnographic research online, which implied the need for a new methodology in mathematics education. And in the experimental part of the research in the mathematical classroom, some attention was needed to develop a task design that could incorporate an out-of-school object, respecting its spontaneous nature. And finally, the last but not least challenge was communicating the research, because it implied talking about objects and the culture that were almost unknown to the majority of scholars. So I will now describe briefly how I dealt with this challenge, starting with the first, which was meaning making. And this problem applied both to the web found memes in the ethnographic research and to students' memes in the experimental research. Analyzing the memes, I made an a priori hypothesis about the existence of layers of partial meanings that add up to the meaning carried by the meme. That is to say, I unpacked the meme into different meanings. The first layer, which I call the social meaning, is connected to the information carried by the conventional value of the pictorial element in the meme, which is set by the social use. The second layer is the structural meaning, and it is connected to the information carried by the font, the phrasal patterns, the overall arrangement of the composition, and this is also set by social rules. And the third layer is the specialized meaning, and this is connected to information carried by text or pictorial elements or addition or mutation of the image that refer to a specific topic, in our case, mathematical. All these three partial meanings are necessary to grasp the message of the meme. If you miss one of them, you cannot decode the meme. That is to say, you cannot understand what I call the full meaning. As for these three partial meaning, I chose words starting with an S. I named this semiotic tool the SSS construct, and it was presented at YERME 11 in the first paper I wrote with Professor Robutti, Meanings in Mathematics, using internet memes and augmented reality to promote mathematical discourse. In this slide, you can see the SSS at work on the Spider-Man meme we saw before. The specialized meaning is the exponential function and its derivative. The structural meaning is carried by the position of the text that are put as labels on the objects of the meme. The social meaning of the image is to represent situations where similar things meet. These three partial meanings add up to the full meaning, which is, of course, we can recognize it, the coincidence between the exponential function and its derivative. During the progress of the research, the SSS evolved from semiotic tool to investigation tool. So it progressed from being a tool to interpret the objects to being a tool to investigate learners' cognitive processes, and a tool for task design for educators. The second challenge was represented by the ethnographic research, because this kind of ethnographic research of digital mathematical objects on the web from the point of view of education had never been done before. So I had to build up a new methodology, merging existing methodology from ethnography in mathematics education, from visual research in social networking websites, and from the research on online informal learning contexts. I conducted this research as a covert non-participant observer for two reasons. Because I am a digital immigrant in the observer culture, and because I wanted to avoid the possible changes in behavior that happen when subjects are aware of being understudied, which is known as the Hawthorne effect. To identify data sources for the ethnographic research, I started mapping the field, and I selected 3 social networking websites where memes are usually shared: Facebook, Instagram, and Reddit. Facebook and Instagram were chosen because they are very popular, and Reddit because it is representative for the culture of internet memes, as it is recognized as the birthplace of the majority of memes. Then the funneling proceeded selecting online communities expressly dedicated to mathematical memes inside these 3 social networking sites. The selection was made according to the number of followers. Here we see the most popular one. In total, I observed around 24 communities. Within the objects shared in these communities, I started collecting my data in the form of mathematical memes that represented topic from the mathematical syllabus of grades 6 to 13. And this chart shows the growth of the population of the meme pool that I collected in these years, which has now reached around 2,300 items. I also collected meta-mathematical memes, that is to say memes whose subject is mathematical memes, like the ones you see in these slides. And these are interesting because they offer insight into how the community relates with mathematical memes. For instance, look at the Tom and Jerry ones that compares how I check my math in an exam, how I check my math when I create a mathematical meme. And also, this gives insight into how the community relates with comments, good mathematical comments that usually are paired up with mathematical memes. In fact, besides memes in this ethnographic investigation, I collected also threads of comments connected to mathematical memes that gave insight into how the community discuss and perceives the mathematics that is carried by the meme, and also comments related to meta-mathematical memes. The ethnographic research proceeded with the coding of the data, which was made according to the principle of the grounded theory with a 2-part code. The first part identifies the template, that is to say the memetic image via its social name, and the second part identifies the mathematical topic. For example, for this meme, the code was Spider-Man and exponential derivative. I analyzed my meme pool and my comment pool, and I conducted a case study, focusing on 2 polar cases that you see in the slide. One mathematically correct, the Hospital meme, and one mathematically wrong, the Spider-Man meme, where the author misunderstood the inverse of the sine function and the 1 over sine function, the functional inverse and the algebraic inverse. And analyzing the comments, I found out that in each thread there are comments that reveal an epistemic need in the users that ask why, ask mathematical explanations, and comments that reveal that other users spontaneously offer informal mentorship, that is to say, user that answers these epistemic needs. And these habits are connected to Jenkins, convergence, and participatory culture that characterize the digital environment. And analyzing this interaction, I concluded that comments to mathematical memes are almost always at the mathematical level, aimed at proving or disproving the mathematical idea encoded in the meme, and almost never at the memetic level. And I also realized that the meaning-making process takes the form of an argumentation that is nurtured by an epistemic culture. And this brought, by abduction, to the conceptualization of mathematical memes as mathematical statements that are expressed in a new hybrid language which merges mathematical elements with memetic elements, rigorously abiding by the rule of both fields, which is the results in the paper I wrote with Professor Robutti and Professor Beckner. So this conceptualization allowed us to understand more the object of the research, as I was now able to translate mathematical memes into something which I was familiar with. The third challenge was task design. It was a challenge because I had to find a way to preserve the social value embodied by the internet memes in students' out-of-school digital life, and at the same time, make the mathematical content sufficiently evident to enable teachers to express some kind of assessment of the student knowledge. So the task assigned to learners was divided into different parts. The first part was a creation task that requested the creation of a mathematical meme on a given known topic, and also something else, a video or a GeoGebra applet that decoded the mathematical content of the meme. And production were shared in a digital sharing space, which was a Padlet wall. The second part was a decoding task, where learners were asked to interpret the mathematical meanings of memes that were not their creation. All production were then discussed in a whole class discussion. The idea informing the design of the creation and decoding task was to preserve the participatory trust of the digital culture. I wanted students to create their own memes, while investigating how learners expressed non-mathematical concepts in a memetic form and transformed them into a verbal, algebraic, or graphical register, and vice versa. And the reason for the choice of sharing the production in the digital share space was made with the aim to preserve the social value of memes, which is connected to the process of tribal reward, which is activated by shares and likes in social networking sites. This table gives an overview of the data collected during the experiments. I collected data related to products, mathematical memes, video explaining the mathematical content and GeoGebra applets, and data related to processes through video recordings of the creation task and of the class discussion. And questionnaires, an entry form aimed at assessing the familiarity of students with memes and social media, and a feedback form immediately after the experiment, and an evaluation form around 2 months after. And in some cases, I conducted personal interviews. And here you can see how I use this data, analyzing them from the different perspective in the bricolage stance that I mentioned before. These are some examples of the memes created in these experiments. And combining together the results of the different observations, I concluded that the hybrid nature of mathematical memes position them as boundary objects in mathematics education between the communities of students and teachers, with the educational potentialities to support various aspects of dialogical learning. And that mathematical memes can initiate epistemic needs and engage students, mobilizing positive emotion, fostering creativity and non-standard abilities, and activating learning facilitators. Last but not least, there was a challenge of communicating this research. I can say that my first presentation, Dylan remembers it, I think, at the YES9 was a complete fiasco. Almost nobody understood what I was talking about, because I had taken for granted that everybody knew what internet memes were, and I did not include a specific explanation. And it was 3 years ago, but it's ages in the internet time. So 3 years ago, there were so many people that really did not know what internet memes were. But it was very important for me to collect the feedback from the academic community in real time during the course of the research. So I submitted and presented the various steps of this research at as many academic congresses as I could. And I learned by mistakes how to do my presentation, especially to include in my presentation and papers a thorough explanation of the internet phenomenon and of the digital culture that constitutes its natural environment. And as I was experimenting with a new educational resource, it made sense also to disseminate my results outside the academia, reaching educators to collect their feedback. So in January 2019, I created a website where I give general information about mathematical memes and I describe the school activities that can be done with memes. And this communication effort has been rewarded. And the map on the left, you see the affiliation of researchers who are now exploring the same topic and have cited my work, among which I am very, very proud to count Backers et al. In this paper on future themes of mathematics education research. And in the map of the right, on the right, you see the locations of schools where teachers have spontaneously implemented experiences with mathematical memes after contacting me through the website. So these are not the schools where I conducted my experiences. These are new spontaneous experiences. So that's all for the thesis work. Then I will quote Michael Cowling again. We are still confused, but we believe we are confused at the higher level. Challenges are the reverse engineering, the creative process of mathematical memes, looking into it through the lens of biassociation theory by Koestler, and this paper is presently under review, and looking into the schemes of usage to transform mathematical memes from mathematics curriculum resources into documents used by teachers. And this is intended using the documentational genesis lens by Godet and Trouche, and this is in progress. So thank you, and these are the references.